Diazonium compounds. Diazonium salts are a group of organic compounds sharing a common functional group R-N+, 2X- where R can be any organic group, such as an alkyl or an aryl, and X is an inorganic or organic anion, such as a halogen. Diazonium salts, especially those where R is an aryl group, are important intermediates in the organic synthesis of azo dyes. Preparation. The process of forming diazonium compounds is called diazotation, diazoniation, or diazotization. The reaction was first reported by Peter Grias in 1858, who subsequently discovered several reactions of this new class of compounds. The most important method for the preparation of diazonium salts is treatment of aromatic amines such as aniline with nitrous acid. Usually the nitrous acid is generated in situ from sodium nitrite and mineral acid. In aqueous solution, diazonium salts are unstable at temperatures above 5 degrees Celsius. The -N+N group tends to be lost as N2. One can isolate diazonium compounds as tetrafluoroborate salts, which are stable at room temperature. Often, diazonium compounds are not isolated and once prepared, used immediately in further reactions. This approach is illustrated in the preparation of an aryl sulfonyl compound. It is often preferred that the diazonium salt remain in solutions, but they tend to supersaturate. Operators have been killed and injured by an unexpected crystallization of the salt followed by its detonation. Azo Carpooling reactions. The most widely practiced reaction of diazonium salts is Azo Carpooling. In this process, the diazonium compound is attacked by I.e. coupled to electron-rich substrates. When the coupling partners are arenes such as anilines and phenols, the process is an example of electrophilic aromatic substitution. Argon mononitride plus 2 plus ARH argon dinitride I plus H plus. Another commercially important class of coupling partners are acetoacetic amides, as illustrated by the preparation of pigment yellow 12, a diarylide pigment. The resulting azo compounds are often useful dyes and in fact are called azo dyes. The deep colors of the dyes reflects their extended conjugation. For example, the dye called anilined yellow is produced by mixing aniline and cold solution of diazonium salt and then shaking it vigorously. Anilined yellow is obtained as an yellow solid. Similarly, a cold basic solution of NaPHTHALEN2 will give the intensely orange-red precipitate. Methyl orange is an example of an azo dye that is used in the laboratory as a pH indicator. Displacement of the N2 group. Arene diazonium cations shows the several reactions in which the N2 group is replaced by another group or ion. Some of the major ones of the following. Replacement by halogens. Sanmar reaction. Benzene diazonium chloride heated with cuprous chloride or cuprous bromide respectively dissolved in hydrogen chloride or hydrogen bromide yield chlorobenzene or bromobenzene, respectively. 6H5N plus 2 plus copper 1 chloride C6 hydrogen chloride plus N2 plus Eu plus. Gatman reaction. In the Gatman reaction, benzene diazonium chloride is warmed with copper powder and hydrogen chloride or hydrogen bromide to produce chlorobenzene and bromobenzene respectively. It is named after the German chemist Ludwig Gatman. 6H5N plus 2 plus CuXC6H5X plus N2 plus Cu plus. Replacement by iodide. Iodine is not easily introduced into the benzene ring directly. However, it can be introduced by treating aryl diazonium cations with potassium iodide. 6H5N plus 2 plus Ki C6H5I plus K plus N2 replacement by fluoride. Fluorobenzene is produced by thermal decomposition of benzene diazonium fluoroborate. The reaction is called the Bowles-Schiemann reaction. C6H5N plus 2Bf-4C6H5F plus Bf3 plus N2 miscellaneous replacement by hydrogen. Arene diazonium cations are reduced by hypophosphorus acid. A sodium stannite gives benzene. C6H5N plus 2Cl minus plus H3PO2 plus H2O C6H6 plus N2 plus H3PO3 plus hydrogen chloride replacement by a hydroxyl group. Phenols are produced by heating aqueous solutions of aryl diazonium salts to 100 degrees Celsius. 6H5N plus 2 plus H2O C6H5OH plus N2 plus H plus. This reaction goes by the German name Phenolverkochung. The phenol formed may react with the diazonium salt, and hence the reaction is carried in the presence of an acid, which helps in suppressing this further reaction. Replacement by a nitro group. Nitrobenzene can be obtained by treating benzene diazonium fluoroborate with sodium nitrite in presence of copper. Alternatively, the diazotization of the aniline can be conducted in presence of cuprous oxide, which generates cuprous nitrite in situ. 6H5N plus 2 plus copper 1 nitrite C6H5NO2 plus N2 plus Cu plus replacement by a cyano group. The cyano group usually cannot be introduced by nucleophilic substitution of halorenes, but such compounds can be easily prepared from diazonium salts. Illustrative is the preparation of benzonitrile using the reagent cuprous cyanide. 6H5N plus 2 plus copper 1 cyanide C6H5Cn plus Cu plus N2. This reaction is a special type of Sanmar reaction. Replacement by a thiol group. Diazonium salts can be converted to thiols in a two-step procedure. Treatment of benzene diazonium chloride with potassium ethyl xanthate followed by hydrolysis of the intermediate xanthate ester gives thiophenol. 6H5N plus 2 plus C 2H5OCS minus C6H5SCOC2H5 plus H2OC6H5SH plus HCOC2H5. Replacement by an aryl group. The aryl group can be coupled to another using aryl diazonium salts. For example, treatment of benzene diazonium chloride with benzene in the presence of sodium hydroxide gives diphenyl. C6H5N plus 2 Cl minus plus C6H6 C6H5 minus C6H5 plus N2 plus hydrogen chloride. This reaction is known as the Gomberg-Bachmann reaction. A similar conversion is also achieved by treating benzene diazonium chloride with ethanol and copper powder. Replacement by a carboxyl group. Diazonium fluoroborates react with an aliphatic carboxylic acid yield the corresponding benzoic acid. This reaction provides a method to prepare aromatic carboxylic acids from aliphatic carboxylic acids. C6H5N plus 2Bf minus 4 plus RCO2H C6H5CO2H plus Bf3 plus N2 plus RF Meerwein reaction. Benzene diazonium chloride reacts with compounds containing activated double bonds to produces phenylated products. The reaction is called the Meerwein arylation. C6H5N plus 2 Cl minus plus Arch equals CHCO2H arc equals C minus C6H5 plus N2 plus CO2 plus hydrogen chloride metal complexes. In the reactions with metal complexes, diazonium cations behave similarly to NO+. For example, low-valent metal complexes add with diazonium salts. illustrative complexes of plus and the chiral at metal complex Fe. Other methods for de-diazotization: by organic reduction at an electrode, by gamma radiation from solvated electrons generated in water, photo-induced electron transfer, reduction by metal cations, most commonly a cuprous salt, anion-induced de-diazonation. A counterion such as iodine gives electron transfer to the diazonium cation, forming the aryl radical and an iodine radical. Solvent-induced de-diazonation with solvent serving as electron donor. Grafting reactions. In a potential application in nanotechnology, the diazonium salts 4-chlorobenzene diazonium tetrafluoroborate very efficiently functionalize as single-wall nanotubes. In order to exfoliate the nanotubes, they are mixed with an ionic liquid in a mortar and pestle. The diazonium salt is added together with potassium carbonate, and after grinding the mixture at room temperature, the surface of the nanotubes are covered with chlorophenyl groups with an efficiency of 1 in 44 carbon atoms. These added substituents prevent the tubes from forming intimate bundles due to large cohesive forces between them, which is a recurring problem in nanotube technology. It is also possible to functionalize silicon wafers with diazonium salts forming an aryl monolayer. In one study, the silicon surface is washed with ammonium hydrogen fluoride, leaving it covered with silicon-hydrogen bonds. The reaction of the surface with a solution of diazonium salt in acetonitrile for 2 hours in the dark is a spontaneous process through a free radical mechanism. So far, grafting of diazonium salts on metals has been accomplished on iron, cobalt, nickel, platinum, palladium, zinc, copper, and gold surfaces. Also, grafting to diamond surfaces has been reported. One interesting question raised is the actual positioning on the aryl group on the surface. An in silico study demonstrates that in the period 4 elements from titanium to copper, the binding energy decreases from left to right because the number of d electrons increases. The metals to the left of iron are positioned tilted towards a flat on the surface, favoring metal to carbon pi bond formation, and those on the right of iron are positioned in an upright position, favoring metal to carbon sigma bond formation. This also explains why diazonium salt grafting thus far has been possible with those metals to right of iron in the periodic table. Reduction to a hydrazine group. Diazonium salts can be reduced with stannous chloride to the corresponding hydrazine derivatives. This reaction is particularly useful in the Fischer-Indel synthesis of trypan compounds and indomethacin. The use of sodium dithionite is an improvement over stannous chloride since it is a cheaper reducing agent with few environmental problems. Applications. The first use of diazonium salts was to produce water-fast dyed fabrics by immersing the fabric in an aqueous solution of the diazonium compound, followed by immersion in a solution of the coupler. The major applications of diazonium compounds remains in the dye and pigment industry. Other uses: diazonium compounds are standard reagents used in synthesis of organic compounds, especially aryl derivatives. Diazonium salts are light sensitive and break down under near UV or violet light. This property has led to the use in document reproduction. In this process, paper or film is coated with a diazonium salt. After contact exposure under light, the residual diazo is converted to a stable azo dye with an aqueous solution of coupler. A more common process uses a paper coated with diazo, coupler and an acid to inhibit coupling. After exposure, the image is developed by a vapor mixture of ammonia and water which forces coupling. Safety. Solid diazonium halides are often dangerously explosive, and fatalities and injuries have been reported. Diazonium chlorides are processed without delay once prepared, but at the low temperature that the diazotization reaction is conducted at, the product in may be poorly soluble in aqueous solvent, and it may happen that one prepared a supersaturated solution that the salt may crystallize out. If done on an industrial scale, this has the potential for disaster. Diazonium salts with weakly coordinating anions are quite stable. In fact, aryl diazonium perchlorates, such as nitrobenzene diazonium perchlorate, have been used in initiating explosives, and well dried. The tetrafluoroborates can be stored almost indefinitely at room temperature and decomposed gently when heated.